right. Hello, everyone. Thank you so much for sticking around. My name is Shoma, and I will be telling you about PulpaTronics, which is a startup that basically focuses on developing more sustainable RFID tags for a greener inventory management. All right, so I just wanted to start by giving you an overview of everything that I will be talking about today. So first of all, I'll introduce our company and our team. Then I'm going to move on to kind of explain the context behind the problem and then the solution that we're using to tackle it, and then explain some details about the innovation and the technological side of things, and then finally move on to how this is something that we're now looking to turn into a business. All right, so who are we and why are we here today? So obviously, we are this year's winners of the Green Alley Award competition that is organized by the Landball Group. And so what you can see on the right here is my co-founder, Chloe, and I basically winning the competition earlier this year in Berlin. And so what you need to know about PulpaTronics is that this is a startup that came out of a master's project from Imperial College London and the Royal College of Art. And this is a relatively young company that has only been running for around 16 months now. And our mission is basically to revolutionize the inventory management industry. So before I go any further, I wanted to kind of introduce the team that I'm speaking on behalf of today. So as you've already seen it on the left is Chloe, my co-founder, so she's the CEO of the company, and then there is obviously me as well. And then the rest of the team that you're looking at right now are basically all engineers and scientists that are kind of like experts in their own areas, covering all sorts of different aspects of the innovation that we're working on. And then we obviously have a few advisors as well. All right. So what is the problem that we're looking to tackle, and what even is RFID technology? So RFID stands for radio frequency identification, and you can basically think of RFID tags as these smart labels that contain electronic circuitry inside them, which basically allows people to identify items using radio frequency communication. And the way that works is these labels are usually hidden, and so they are very, very beneficial for just inventory management in general, but also for anti-theft prevention or theft prevention, and even self-checkout machines as well. But then did you know that every year over 18 billion of these RFID tags are manufactured, and because they contain a metal antenna on the inside and they have a silicon microchip as well, they are pretty resource intensive to make, quite costly as well, and then they're also polluting. And if you think about it, when you and I go home and then pull off one of these hang tags from an item of clothing, for example, once we throw that away, it usually ends up in a landfill, essentially contributing to electronic waste. So this is something that PulpaTronics kind of set out to tackle, and this is why we kind of invented our fully recyclable, metal-free, and chipless RFID tags that cut 70% of the CO2 emissions associated with the materials embedded in the product, and it also is twice as cheap as existing alternatives. So how exactly are we able to do that? It's basically a combination of three pieces of technology. So we start with our bespoke paper substrate, which we then kind of like hit with very specific laser settings that trigger a chemical reaction inside the paper substrate itself and turns it into a conductive material. So with the help of this laser, we are basically inducing an electronic circuit on our paper substrates, and then we are doing that in very specific geometrical shapes that allows for storing the information in a geometrical pattern rather than using a microchip. So basically what this allows us to do is we are now using a lot fewer components, the entire manufacturing is much simpler, and the end product is essentially paper recyclable. All right, so just to recap some of those steps that I've just been explaining. So we start with a highly specialized kind of paper substrate that we've optimized for this purpose, and then we laser it to create our circuitry, which then stores the information in a geometrical pattern, and this is what you can see on the right as well. So in terms of where we are with technology validation, so this is something that we've already validated 2 years ago at Imperial College in a near-field communication lab, and then last year we were able to kind of further develop our tags and test their durability in collaboration with Cranfield University, our partner. And then this year, what we are doing is we're focusing on developing our own reader machines and then testing those as well. And this we are doing in part of a collaboration or as part of like an Innovate UK grant project in collaboration with a few partners. So I guess just to give you a little bit of idea of the intellectual property associated with all of this, so we filed a few patents. We've actually just filed an international application last week, so I think this is now 3 patent applications, and we have a few trademarks and trade secrets as well, obviously. And then, all right, so this slide is just here to kind of give you an idea of what our product range could potentially look like and how we imagine going to the market with this, this idea. So in 2025, we're looking to launch what we are now referring to as our hybrid tags. The reason why we call them hybrid tags is because they are kind of like an intermediary step between commercially available conventional RFID tags versus our ultimate kind of like end goal product. And so what this product does is kind of like the perfect stepping stone for us in terms of R&D. And it is also still very much compatible with existing RFID infrastructure. So it basically allows us to go to market quicker and start generating revenue and then eventually propel us to launching our second product in 2026, which is what we are referring to as a security tag, and that's what you can see on the left as well. And then eventually, after all of that, we're also looking to license out this technology as kind of like a third revenue stream. And then the way we imagine that is essentially we would be integrating our laser machines into existing production lines for like a packaging manufacturer or label manufacturer, for example. So what that would allow them to do is basically directly laser their own RFID tags onto their product. All right, so this image is just here to give you an idea of what some of the prototypes currently look like. So these are the security tags that we are currently testing with our partner Petit Pli, who you might have heard of. It's an eco-challenger brand based in London who design clothes that kind of like grow with children. And they have a store in the Battersea Power Station, which is kind of the perfect kind of retail environment for us to test our technology. All right, so how are we looking to turn this into a viable business proposition? So if you look at the RFID market or the RFID landscape, what you can see is that there are quite a few competitors, but no one in the industry is commercializing metal-free RFID tags, which means that their costs and their emissions are much higher than ours. And even though there are some players who are looking to or have already developed slightly more sustainable RFID tags than the conventional ones, they typically offer these at like a premium price point. So even though it's in their portfolio, it doesn't actually get adopted by the market because no one's actually buying these tags. So we really come in as a more sustainable alternative that is also more affordable. All right, so just looking at the market, so the RFID global market is looking to grow to $36 billion by the end of the decade, and 60% of that is going to belong to the fashion industry. So we're looking to kind of start with UK-based, sustainably focused fashion brands first, which we estimate to be around £20 million, and then we would then want to be diversifying into other industries like packaging, logistics, even hospitality. And then in terms of kind of like our material substrate that we are using, we want to explore more plant-based materials, not only paper. And then I think what we're looking to kind of understand a little bit more is definitely cork, which is like obviously super relevant here in Portugal, and then cotton and even bioplastics as well. All right, so in the last year, we've been able to talk to 70 different stakeholders from industry, and most of these were through inbound requests. So we were in a really lucky position to be able to land 8 letters of intent and 3 pilots already kind of secured for next year. All right, just quickly, so we are part of 9 different like incubators and accelerators right now, and we've already graduated from probably like a dozen of these. In terms of the awards, we've won quite a few design and engineering related awards, and obviously the very prestigious Green Alley Award by the Landbell Group. Once again, and just to wrap up, I kind of wanted to paint a picture of what is next for PulpaTronics. So together with the Henry Royce Institute and our kind of paper research partners based in Sweden called Sting Bioeconomy, we are currently building our in-house production line, and that would basically allow us to create large volumes of these tags with a consistent kind of quality, which then would enable us to do our pilots in Q2 and Q3 of next year. And once we've kind of evaluated the tag's performance, we would then be able to expand scaling up a little bit more. All right, so you might think that these RFID tags are very, very tiny, but if a major retailer like Zara, for example, would switch to our tags, they would already be able to save 2% of their entire year's greenhouse gas emissions, which is quite a bit. So with PulpaTronics, what we're looking to do is basically take a piece of advanced technology and make it more accessible to people by making it more affordable while keeping it sustainable as well. Thank you, and I'm happy to take questions. The growing of the kids? All right, so Petitpli is this amazing research collaboration partner that we have. So they're developing, they have this very interesting fabric that has a unique folding pattern. So what it does is that you can kind of like stretch it, and the folding pattern allows for it to expand. So it means that when you have a child, you don't have to buy new items of clothing in the early part of their growth phase when they're just like getting bigger and bigger every week, but instead the clothes kind of expand as your children go. It's a very cool startup. You should all check it out. All right. I have teenagers. Cool. If there are no more questions, I came with a few asks. I have a couple more minutes left. So as I was kind of explaining, we are now looking to deliver on some of these pilots, and we're always obviously on the lookout for grant applications. So currently there is a grant application that we would very much want to apply to, and it's a bilateral collaboration between the UK and Germany. So if anyone knows of any SMEs in Germany who would be interested in operating in this space, if they have anything that needs to be tagged or have some cool biomaterials, yeah, just find me and let me know. So I would be very open to learn about that. So that's, and then if you know of any kind of like company or startup who is working with cool plant-based materials, cork included, but any other material, we would always love to be able to chat with them. So again, just let me know. Right? Was there a question?
There still was a question.
All right.
Hello, yeah. Interesting technology. One question. At the moment, you have this paper substrate, and this is an extra piece, so to speak. How thinkable would it be to integrate your technology onto whatever kind of substrate that already is part of the product?
Right, very good question. So yeah, obviously what we're working with right now is kind of like a fine-tuned like paper material, but there is nothing like crazy in it. We're not adding like nickel particles into it or silver or anything. So in theory, whatever we are doing works with pretty much any kind of paper. Just some paper coming from certain pulping processes kind of work better with our application. Something that we're looking to explore a little bit more as well is like, could we essentially like spray or like put an additional layer on whatever substrate and then laser over that, and then that would basically allow kind of any paper-based material to be suitable for this application. Again, something that we're just kind of like researching and trying to understand more. But as long as you're working with something like cardboard, the good thing about our technology is that it works with the cheaper kind of papers, which is like quite nice because those appear quite more often in the packaging industry. And then also cork as well, like if you just think of like wine bottles, for example, or cotton as well, like quite a few of the materials I think would allow us to explore quite a few options there. Yep. Right.
Bin. Is that it?
So the question was, once you remove the hang tags from the clothes, does it go straight into the bin? Well, I think that depends. It depends on what country you're in.
Yeah,
I think
just to add up, because it's very annoying, at least for me, whenever we buy a piece of clothes that I don't buy for years, but there's a lot of tags, like on the back here, I take them all, but then there are sort of things that I want to put it in the recycling bins, but it's just, besides being annoying and then scratching your skin, you cannot remove it as well. You have to be like with a scissor cutting it off, and it would facilitate everything. And I think if the whole process was just one tag that just applied with paper.
So this would be particularly kind of looking to replace like these short-lived kind of single-use paper-based items like clothing hang tags, so not the ones that are actually sewn into your garments, but the ones that are hanging off of it. And then you would just basically be able to put it straight into paper recycling, which in the UK is...
But usually, as you know, a lot of times that part is like strapped with the plastic part,
right?
You know, where you have to cut it. So you could be like, you could enforce people not to use that as well, because you know what I'm talking about, right?
Yep,
They put the plastic part to handle the cardboard part.
Yeah, it's a very good idea for sure. I'll pitch that. Cool. Well, thank you so much for your attention then. All right. Thank you.